Hello everyone, I'm Raymond. Welcome to part 3 of the AWS Fundamentals Recitation. In this part, we are going to talk about how to configure the EC2 instance for your homework. This will include how to edit your code stored in the instance more easily, how to install necessary packages, and how to back up your setup. First, let's go through how to set up your SSH configuration file. From the previous section, we've already seen how to connect to the EC2 instance through terminal. However, it is very hard to edit our code through the terminal. An easier setup is to use VS Code integration. Now let's open VS Code and click on the Extensions button. Search for Remote SSH extension and install it. Now I already have it installed. After installation, we will see the green button here. Click on it and click Open the configuration file. Now we need to add some detailed information about our EC2 instance. The format can be found on our slides. I'll copy it here. For the host, we need to copy the public DNS of our instance. On our EC2 instance page, click on Connect SSH Client, and we can copy the public DNS. For username, the default is Ubuntu, which can be found here. And the identifier is the path to the perm file we created before. Here, I placed my perm file under the .ssh folder. Now we can click the button again, connect to host. We can see that this host already shows up. Here we can see that we are already inside the EC2 instance. Now let's try to create some folder and code. We can see that it's much easier to navigate and edit your code using this extension. Next, we are going to talk about the environment setup for this course. First is the Conda setup. We are going to doing the demo using EC2 instance with deep learning AMI. This image already has Anaconda installed and is much easier to use. If you want to customize your Conda environment, you are welcome to choose the deep learning based AMI. The steps to install Conda are listed here on the slide, but I will skip the process here for simplicity. Now in our instance, Anaconda is already installed, but it's not showing up here. We first need to run the init code to activate it in the bash. Then we need to close and reopen the bash. Now our Conda environment is ready to use. Next, we want to create a new Conda environment to manage the packages. Here we create an environment named IDL with Python installed. It is recommended to have separate environments for different things to ease the trouble or version conflict. For example, you are recommended to create different environment for your homework and project. Now the environment is installed. We can run this command to activate the environment. Now inside the environment, we can use pipe to install the whatever packages we need here, like NumPy and Torch. Just use this as the example. Finally, we need to set up Kaggle. We use Kaggle for our homework part 2. It has a command line tool that enables us to download data and make submissions. To use Kaggle, we first need to install it using pipe. After this, we need to create a directory under our home directory named .cargo. Next, we need to go to our Cargo web page. Select your profile, then the Account tab. Click on the Create New API token. We can see a file is downloaded. Let's open the file and copy the content inside. Then we run this command to write the content inside a file named cargo.json. Now let's type the command cargo to see if it's working. We should change the permission. And yet it's working right now. Next, let's talk more about the storage for your EC2 instance. When you create a G4DN instance, by default, there is a 125 gigabytes instance storage associated with it. However, the storage is not ready to use with some additional steps. First, go to the terminal inside your EC2 instance. Use the lsblk command to check the information for different storage devices. Here we can see that this device has the storage amount closest to 125 gigabyte, and this is the storage device we are looking for. Remember its name. Then we are going to run this command to make a file system on this device. Next, we can create a folder. Here I'm going to make one named data. You can create with any name with any location. Then we run this command to mount the file system we just created to the folder. Lastly, we need to change the permission of the folder. Now, this folder is ready to use and has 125 gigabyte storage. The instance storage here will be erased if our instance is stopped. So the storage is not suitable to store important data, including your code and trained models. If we want to store things permanently, we need to use persistent storage. There are two options, Elastic File System EFS and Elastic Block Store EBS. EFS offers a file system managed by AWS with scalable storage size, while EBS offers block storage similar to a hard drive with a fixed size. Both options offer enough storage and performance for us to use in this course. EFS has the feature to allow connections with several instances, so if you plan to share the storage with several instances at the same time, you should choose this option. On the other hand, EBS is cheaper. You can choose either option based on your preference. It is highly recommended that you set up one of them so that you don't lose your data facing AWS instance crash or Spot instance termination. Next, I'm going to demo how to set up both of them. Let's go through the setup for EFS. The first step is to update the network setting for our EC2 instance. Let's go to our EC2 dashboard. Under Network and Security, find the Security Groups tab. Select the security group for our EC2 instance. Under Inbound Rules, click Edit, and then click Add Rule. Change the type to be NFS, which stands for Network File System. Change the source to be 0, which means any IP source. Click Save Rules in the end. Then let's go to the EFS dashboard. Change the region to be the same as your EC2 instance. Click Create File System. Click the File System ID, then click Network tab. Here, the mount target state is still creating. We need to wait for a while. Now the mount target state becomes available. Then we click on Manage. Add a security group to include the security group for our EC2 instance. Then click Save. Now the previous two steps both enable the EC2 and the file system can talk to each other. Next, click the Attach button. Copy the command under using the NFS client. Then let's go to the terminal inside the EC2 instance. Make a directory to where we want to mount the EFS. Copy the command we just pasted and update the last path to be the folder we created. Lastly, we need to change the permission for this folder. Now EFS is set up. Here, I have created a file and stored to EFS. If we terminate this instance and restart a new one, we simply need to repeat the process here to connect to EFS. After this, we can see the same file showing up inside this folder. Next, we are going through the setup for our second option, EBS. Go to EC2 dashboard. Under Elastic Block Store, select the Volumes tab. Select Create Volume. We can change the type and size here. The default option works fine. For availability zone, we need to set it the same as our instance. So let's go back to the EC2 instance page. And we can see the availability zone here. So I need to change it to 2C. Then we can create it. Let's wait for the status to be available. So the next step is to right-click on the volume and then select Attach Volume. Choose our instance from the drop-down list. So now the EBS volume is already attached to our instance. The remaining process is very similar to set up instance storage. We need to create a file system and mount a folder. So let's go to the terminal. First, use lsblk to check the device name again. We can see this device has a 100 GB storage, which is the EBS volume we just created. Then we use this command to create a file system on this device. Next, we create a directory. And mount the EBS volume to this directory. The last step is to update the permission for this folder. Now the setup for EBS is finished. After the setup, you don't need to repeat the process of creating file system if you just stop the instance. But you do need to repeat the process of mounting each time you restart it. To share data between different instances, the way you do that with EBS is to first detach it from current instance and then reattach it and select another instance. One thing to notice about the persistent storage is that since it is not related to your instance, remember to delete EFS and EBS as well when you finish using them. For the last part of this video, we are going to talk about environment and data backup. If we don't want to go through the entire environment setup process for new instances, we can pack our environment in a TAR file and unpack it in a new instance. For example, we can do this for our Conda environment, cargo setup, and even batch setup if we want. Let's use Conda environment as an example. We can use this command to find the path to our Conda environment. In my example, I'm using an environment named IDL. We can see it's under this folder. Let's go to the folder. And then we can create a TAR file. Now we can see I'm saving the TAR file to the persistent storage. We can see that our environment TAR file is saved in the persistent storage. Now I have another instance running. Let's go ahead and connect to this instance and set up the environment. I already set up the EFS before. We can see that the environment is available here as well. Let's follow the steps and unpack the environment. We can see that the IDL environment is replicated here. With this example, we can see that the environment is easily replicated using persistent storage. In addition, we can also back up our data. It is highly recommended that you save your trained models in your persistent storage so that you can restart training by loading intermediate checkpoints if training is interrupted.